Metal matrix composite application. Metal matrix finds lot of application in automobile industry. First it is in automobile and then it is in aerospace. Aerospace industry, they wanted to have high strength, so high strength they want, and then they want high stiffness. They wanted to have low coefficient of thermal expansion and it has to be lightweight, because if you can reduce 1 gram or even 5 grams of weight here in aerospace industry, you make a huge saving in your fuel, because here you have to carry your fuel and go. So, that is why in aeroplane and in rocket they always try to replace all the metal parts by composites, so that they can have lightweight materials, so that they can meet out their application. And here it is also very high temperature. Polymer matrix composite cannot be thought of in the first way because of the temperature. And you can see the top of the rocket can be done. The exit of the fire nozzle, that also is nowadays made out of composites. So, a huge application finds in aerospace industry, wherein which metal matrix composite plays a very important role. Here aluminum matrix is used, titanium is used, magnesium is used, and high entropy alloys are also used, so that they form composites. So, the total weight saving of 145 kilos, that is 44% of weight reduction happened, and the cost, material cost was, it also gave a huge reduction. Next is automobile industry. Automobile industry had a huge impact for a common man, because they have a fuel efficiency is one, and then they also try to enhance the stiffness. So, moment the stiffness enhances, during accident or crash, these materials tries to yield and tries to transfer energy such that the passenger is slightly safe. So, the brake drum is made out of metal matrix composite. Earlier it was made out of cast iron, now it is made out of metal matrix composite. Wheel rim, titanium rims are coming up today with metal matrix composite, and then you will have piston which is there for a long time, which is coming out of metal matrix composite. So, they make through a process called a stir casting, which we will see later the different processes. So, and then they could make. So, basically if you can make a casting from a metal alloy, then all these things can also be made through metal matrix composites. So, brake drum, brake disc was a big advantage. So, there we used aluminum, and then we reinforced with SiC particles. Then this is used in Toyota car company, and all the major giants started pushing very hard. So, the engine is now made lighter, the silencer is made now lighter. Silencer are made out of today titanium alloys, and these titanium alloys now move towards titanium composites. So, the other thing is you can see the front and rear discs. Completely these discs are made out of metal matrix composite, and when you talk about all these discs, they are all made out of aluminum. So, this is aluminum alloy, aluminum, Si and Mg, this is an alloy in which we have reinforced with SiC, and it is a particulate, it is particulate. So, that is what is told here. So, the moment they do it with this, the disc temperature enhances. Moment the disc temperature enhances, the efficiency of braking enhances. So, the car weight is nowadays also reduced to. So, moment you reduce the car weight, the mileage goes high. So, that is what people are looking for. People are looking for because of carbon footprint and other things, people are looking for less pollution, longer distance of travel and safer travel. So, these are the things people are looking for. So, that is why composites are coming up in a very big way, and wherever there is high temperature, wherever there is a strength point of view coming, a thermal point of view coming, we replace it with metal matrix composite. So, drive shafts is another big example which is made out of today metal matrix composite. So, this 6061 is the alloy, they are reinforced with alumina with particulate size, and this is used by different companies, GM, Ford, all these people are using it for their drive shaft. So, engine parts. So, engine parts, I told you this is an engine block which was earlier made out of, it was made out of cast iron, from there it went into aluminum. Today people are making it out of titanium, and from when aluminum and titanium are made, so they are slowly getting into the field called as metal matrix composites. So, here aluminum reinforced with SiC is done, aluminum reinforced with alumina is done, Ti with TiCN, TiN, they are also tried. So, and then they try to mix and then try to get, and then here they also try to reinforce with particulate size or particle size or even short fibers. The only difference is aspect ratio. So, length by diameter. This will have a shorter fiber, will have a longer length. You can also try to reinforce with whisker. So, if you see here, the rest of the portion, the rest of all the portion will be made out of aluminum alloy, and only the top portion will be made out of metal matrix composite. This portion alone will be made out of metal matrix composite, wherein which ceramics is reinforced. The ceramics, what they do is they try to make something like a preform, and then in the preform there is lot of vents holes, or there are some holes in between gap. So, through this gap the aluminum is pushed inside. So, we will see the process. When you study the process in depth, you will understand how do these applications are being made. So, this is done by squeeze casting methods. These are liners which are used. So, they are also made out of metal matrix composite. All the big giants, GM, Toyota, Hyundai, they are all trying to replace with metal matrix composites. Train. So, in train also, see today today these trains, the number of coaches in the train has increased from 16 coaches to 24 coaches, at least in India. They are all 21 to 24 coaches, and if you talk about goods train, they take 50 coaches. So, the biggest problem is braking system. Moment you apply brake, it has so much of momentum, it keeps pulling for almost a kilometer and then stop. So, if you want to have instant braking, and if you want to have the discs which can withstand very high temperatures, then metal matrix composites are tried there. So, braking disc and braking drums are today made out of metal matrix composite. So, they are made lightweight so that they can increase the mileage. So, lightweight is made and it can withstand high temperatures. So, the weight of the disc is 74 kilos, which is replaced from cast iron. They have got a weight reduction of 40%. So, the total weight saving is 10 tons for a train if you can do. So, on successful testing, they could go over 1 million kilometers. Okay. So, this in trains, railway coaches, they are also making railway coaches also, there are railway engine, they are making copper based composite to withstand high temperature, and in the breakers, circuit breakers, they are all making out of today, which was earlier bimetallic, now they are all made out of copper alloys, and discs are made out of aluminum, they are also made out of copper, which is reinforced with graphite so that they give lubrication. So, all these things are now tried in a big way. So, when you go to plane, so 50% of them are now today, wherever it was possible, 50% of them are now made out of metal matrix composite. They are made out of aluminum metal matrix, titanium, steel and others. Right, these are the applications. So, if you see titanium, where do we go for titanium? Wherever there is a weight reduction you want, we go for titanium. But what is the biggest challenge? Why people are not going exclusively for titanium cast compared to that of aluminum? Processing of titanium is difficult. Titanium alloy, titanium mixing with particulate composite without having a reaction is a big challenge. But whereas aluminum, it is very easy. So, that is why people always prefer for processing of aluminum is easy. So, aluminum is used as well as titanium is used. Titanium processing is little difficult. So, if you see, this is what it is. So, now all the exit you see titanium, because high temperature titanium is used. Wherever there is not much of load, but still you need some amount of strength, you see aluminum. So, these are some of the places where aluminum is used in a plane, and you can see also steel, even now steel is used, and so this is other composites, and see wherever there is a hot exit air, they always go for titanium alloys. Okay, titanium alloys or titanium metal matrix composites. right. So, these are something which you should make sure, and when I say others, others small, these are all rare type metal matrix composites which are used for particular application. So, aerospace industry it is also used. So, this is what we saw in a previous figure. So, you have fan exit guide vanes which are all made out of titanium today. So, look at a man and look at the massive size of the turbine whatever is used. So, look at the massive, it's Boeing 777. So, look at the size. So, this is made out of titanium and they have lot applications. So, this engine is Part Whitney engine 4XXX series which is used in Boeing 777. Lightweight. So, that is why people are making, and here interestingly whatever casting you made earlier the same process can be used, but you should keep it in mind now you are with the alloy you are adding some reinforcement which are lighter weight. So, there will be a difference in density. So, you should make sure that it is homogeneously distributed, or if you want to have functionally graded that is also possible. Functionally graded means with respect to distance the property changes, whatever property you want. If you take this as 0 exposure to the surface, you can have a sudden decline and other things, so that you meet out the applications. So, metal matrix composite using titanium. So, here are some of the other applications which we have put very clearly. So, you have the potential application is national aerospace planes. So, here you see that who is the manufacturer I have given here clearly, and what are the candidate components, and then what are the benefits we get. If you see here, you see weight savings, higher temperature, higher operating temperature you always get. Same way with advanced aircrafts, you can see the life cycle cost savings. Life cycle cost savings is right, you reduce the weight of the component and you start using it using a fuel, and if you could try to find out a break even, when do you get back whatever investment you have made. So, that is what is life cycle cost savings we see, and then you can see in gas turbine engines is a big way. So, the weight savings, and you can go for higher temperature. When you can go for higher operating temperatures, you have a better combustion happening. This is pretty interesting. So, these are electrical conducting cables for power transmission, which I just introduced in the previous class, or in this class I introduced. So, here if you see, there are some number of small wires. These wires are tied inside and then they put a sleeve on top of it, right. So, these things what they do is, these are transmission towers and these are wires which run for several kilometers. In order to avoid the wire getting sagged, we support at several points. So, each supporting point is made out of a tower which is huge investment cost. It occupies land and then it occupies also a huge investment to make these structures, and whenever you have a natural disaster, these structures are prone for failure, and again doing it back, relaying it back takes a lot of time. That is why people have today nowadays gone for underground cables. They are not going for overhanging cables, they are all going for underground cables. So, that has its plus and minus. So, here coming to this cable, initially these cables were made out of conducting material like copper, aluminum and other things, but they figured out as and when the load on these, why that means to say the drawing power goes higher and higher and higher, these materials start sagging. In order to avoid this sagging to happen, you have to add more and more towers. So, now what has happened is, by the coming of metal matrix composite, and if they could make it out of aluminum, the density went down drastically, the coefficient of expansion went down drastically, the conductivity enhanced by this many %, and now the number of towers are reduced and they have transmission of power with lesser losses, which is a big boon for transmission industry, power transmission industry. Gas turbine can be used in aerospace, it can be used in marine industry. So, these I have already dealt. So, these are the advantage: high strength, low weight, ability to perform at high temperature, make metal matrix composite the material of choice for gas turbine engine components. So, if you see the market force, so you see in ground transportation, which earlier was 16,000 now tons, it has gone up to 1,600 tons, it has gone to 3,400 tons. Thermal management, it went from 668 to 1000, and this aerospace and defense, it went to this. So, and then you see industrial, other recreation from 152 to 220 it went. So, you see in 1999 2.5 million kilos were used, and in 2004 it has gone to 4.9, and in 2014 this is for 2014 we are showing, and for 2004 also it has increased. So, now they are finding lot of applications for metal matrix composites in transportation industry and predominantly for thermal management. So, with this we come to an end for the lecture, and wherein which we have seen lot of applications, and then we have seen the introduction of metal matrix composite. So, I have given enough of basic knowledge for you to appreciate metal matrix composites. So, I would like to give an assignment. This assignment is like, try to look at any entertainment industry, and then you see where all they have used metal alloy. And people might ask, what is entertainment industry, wherein which here where there are secondary structures usage, secondary structure use. There are a lot of secondary structure use. So, wherever there is metal alloy, can you replace this metal alloy by composites? If so, what are the components? What are the components? Okay. Just try to make a list for yourself, and then you will try to see whether it is worth making it. And here keep in mind cost. Cost is a major factor. You keep this in mind, and then you look at all the entertainment parts, entertainment compounds, entertainment parts, and then see where there are used metal alloys. Can these metal alloys be replaced by composite, and if so, what are the components will you do? And you see, keep cost as a major thing. So, that is very important, and then you try to make a list. With this you try to do, and you do not have to submit. So, you try to have an assessment for yourself, and if you cannot find out from the live examples, you can of course use internet and start browsing it and understanding how do the people try to decide whether this alloy has to be changed into metal matrix composite. Thank you.